I want to start with a pretty simple question. What is a number? Pause the video for a moment and write down your description or definition of what you think a number is. Welcome back. It seems like it should be an easy question to answer, right? You've been using numbers a lot for a lot of things for a long time. We can give examples of numbers. We can show how to write them. We can talk about how to use them, but it's hard to say exactly what a number is. So in order to do that, I'm actually going to cheat a little bit. Instead of talking about what a number is, I'm going to talk about what numbers are, and I'm going to do that by talking about what we invent numbers to do. So let's start with a simple situation. Imagine that we don't have numbers, but we do have a donkey. Right? So numbers don't exist in this situation, in this scenario. If someone asks me what I have, I can say I have a donkey. That's not hard to do. I don't need numbers to do that. But what if I get more donkeys? What if I'm just going donkey crazy and I just start collecting donkeys, and then someone comes back and asks me what I have? Now, how do I answer that question? I can say I have a donkey and a donkey and a donkey and a donkey and a donkey, but that would get really annoying really quick, and they still wouldn't really be able to say how many donkeys I have. So wouldn't it be great if there were a way for us to talk about all of these donkeys at once instead of having to talk about them one at a time? Let's go ahead and invent a way to do that. Let's just say that what I have here is something called a 5 donkeys, and we'll use that symbol there to represent the idea of having 5 donkeys. Okay, yay! We've got 5, but wait a second, hold on. What does 5 mean? We just said we're going to have 5, but we need to invent that idea first. So how do we invent 5? How do we do that? Let's maybe start with a simple invention. Let's start with the idea of 1. We have to start with that sort of basic idea of 1 being one thing. The singular, the only, the non-plural, el uno. It's essentially the lowest number of things that you can count. It's 1. Once we've invented 1, this is actually going to be pretty easy to invent some other numbers. We could invent the number 2 simply by saying that 2 is 1 with another 1. Similarly, we can invent 3 by saying that 3 is just 2 with another 1. We can invent 4 by saying 4 is just 3 with another 1. Right? So we can invent each number that we need simply by taking the number before it and saying it's that thing with one more 1. So the idea of 5 is just going to be the idea of 4 with another 1. So we've just invented 1, 2, 3, 4, and 5. And you know, invented doesn't feel like really quite the right word. Maybe instead of saying we invented those numbers, we could say that we've just defined those numbers. So we've given a definition for what 5 means here. 5 is essentially just a 1 and a 1 and a 1 and a 1 and a 1, or it's 4 with another 1. And why do we do that? Well, we created those definitions so that we could use 5 to describe how many donkeys I have. Ultimately, what numbers are is a tool that we use to describe quantities. We use it to describe amounts. And the great thing about these ideas is once we've defined this idea of 5 for donkeys, we can use it to describe all sorts of things. We could say that we have 5 donkeys, or we could say we have 5 kitty cats, or we could say we have 5 grumpy cats, or we could say we have 5 hot dogs. Oh, I'm hungry. We could even say that we have 5 of another number. But all by itself, essentially what 5 is it's counting 5 ones. It's the idea of having a 1 with a 1 with a 1 with a 1 with a 1. Let's be careful, because we can use numbers like 5, 2, 9, and 8 to describe quantities, but they only help us describe quantities and to represent quantities that we know. What do we do if we don't actually know what the quantity is? This might be a weird question at first, but let me just kind of clear up some things. 5, 2, 9, and 8. those are all numerals. They're the shapes, they're just pictures, they're symbols that we use to represent the ideas that we defined on the previous page, right? We use that kind of curvy looking with the squarish part on top shape that we call 5 to represent the idea of 5, right? What are these things? A, M, X, and Y. We think of them as letters, but they're not letters. I know you think I'm crazy, but really they're just the characters, they're the shapes, they're the symbols that we use to describe letters. We can use those same symbols, those same shapes to represent numbers. So let's say you have a box full of monkeys. Can you tell me how many monkeys are inside that box? No? Why not? Well, obviously because you don't know what the quantity is. But do you know that there is a number of monkeys inside that box? Yes, there is some number that describes the quantity of monkeys in that box. It's not a we can't use a number though like 2, 3, 4, or 5 because we don't know exactly what that quantity would be. So instead, we can use a character like X to describe the quantity of monkeys inside that box. So let's be clear. There are X monkeys inside that box. Now I need to ask you the most important question of the day. Is X a letter or a number? X is a number because it represents a quantity. I know it's the symbol that we use for the letter X, but in this case, that symbol, that shape, is a number. So let's ask ourselves some questions. What could X plus 5 mean? Take a moment, pause the video, and write down what you think X plus 5 could mean. Your sentence might start like this. It might say, X plus 5 means... Pause the video now and write that down. All right, here's what I think X plus 5 could mean. It's one of the ways we could say this. There's what X is, right? X is the number of monkeys inside of one box. Now, if we had that box of monkeys and we also had 5 more monkeys, the amount of monkeys I have would be X plus 5. It's that unknown number plus 5 more monkeys. Take a moment to look at the answer you wrote down and see if you'd want to make some adjustments to it. Go ahead and leave the original answer you wrote down, though. I'm going to ask you another question that maybe is a little bit trickier. What could that mean? What could 5x mean? I will give you this one hint. We will usually read it as 5x, but we could also read that as 5 times x. Take a moment to write down what you think that number could mean. All right, here's sort of the way that I would describe what that number means. 5x means that we have 5 of this thing called x. Now, x is a quantity, remember? X is the number of monkeys that we have in that box. So when I see 5x, what it tells me is that the quantity that we have total is the same as if we had 5 of those boxes, right? So here's how many monkeys we would have with one box, right? We would have 1x. If we had 2 boxes, we would have 2x number of monkeys. If we had 3 boxes, we would have 3x would be the number of monkeys we had. If we had 4 boxes, 4x would be the quantity of monkeys we have. But since we want to be talking about what 5x means, we would be talking about the number of monkeys we have if we had 5 of those boxes. To me, that's the easiest way to describe what 5x means. In the previous example, we used a character symbol to represent a number that we didn't know. There will be other times that we use alphabetic characters to represent numbers. Pause the video and read through the text below, then unpause the video for our final question. All right, welcome back. When we use alphabetic characters to represent a number, we usually just call that number a variable number, even though sometimes the number is really not variable. It's really a misnomer to call it a variable because sometimes the number is an unknown constant, like in the previous example. The number of monkeys inside of the box didn't change. It didn't vary. What I'd like you to do now is I'd like you to go ahead and write down definitions for 5 things. I'd like you to write down the definition for variable, independent, dependent, unknown, and constant. Once you've written those down, I'd like you to explain what it means to say that it is a misnomer to always call numbers represented with alphabetic characters variables. You might want to use Google to help you find some book definitions and then write them in your own words. Your answer for the question of what it means to say it's a misnomer might start like this. Calling all numbers that we represent using alphabetic characters variables is a misnomer because, and then you fill in the rest.